1.6, the programming process. What it takes to put a program together. There are 9 steps that you want to go through in order to make sure you have the correct solution delivered to the correct problem. The first one is problem statement. Clearly define what the problem is to do. This is where most of the people fall short of a good sound solution to their problem, because when they are defining the problem, there's a tendency to insert in it some extra material that's not required, or sometimes adding part of the solution into the problem definition, which is totally misleading. A famous saying goes with me for a long time. I remember that from a long time ago. It says, a well-defined problem is half the solution. If you don't have a clear idea of what your problem it is that you want to solve, you definitely would not be able to give the proper solution to it. You should be able to clearly identify the elements in the program that you want to write in the problem statement. You should be able to identify what the output is desired and design that output first. You got to be able to come up with a solution of how to get that output, and finally go after gathering what your input should be. The next part is visualizing the program running on a computer step by step, or a walkthrough of your solution. You got to be able to act as if you were doing the task of the problem solving using paper and pencil step by step, without any presumption of the thing that might bring your heuristic problem solving in an algorithmic form of the systematic problem solving. You cannot default or make any assumption on the behalf of the computer, since the computer doesn't have any knowledge or any pre-notion of any assumptions. You got to clearly define every detailed steps necessary for running a program, and you have to be able to visualize that step-by-step execution in your mind. You can use tools such as hierarchical chart, flowchart, or pseudocoding to create a model of your program. In this course, we are going to use structured chart for a hierarchical chart to break down a problem into subproblem and divide the subproblem to smaller subproblems, and so forth and so on, till you get to a piece of program or a module which is independent of other parts. And that is where you start building your code for each piece independently. We would be using Visio. At the end of this lesson, there is an exercise that we want you to go through and look at the demo of how a problem is divided into subproblems and subproblems to further subproblems using the tool for hierarchical chart. The flowchart basically shows you the flow of the logic in your program as it's being executed with different data at any different time. This is another tool that we would be using in this course. And finally, the pseudocode, or something that looks like a code, which we already did one example of it in when we were trying to define how to obtain the input from the user to calculate the gross pay and give the result out. The pseudocode can be written in any language, any programming language, or English, without worrying about the syntax of the language, just being concentrated on the logical expression of the solution. Once you developed the solution with these design tools, then you check your model for any logical errors, such as correct calculation for the pay, or correct ingredient of any formula that goes together to produce the result, correct steps that are being taken in order to resolve your problem. The next part is you're going to take your pseudocode and code it into a programming language of your choice. In your case would be C++. Roughly every statement of your pseudocode will translate to one statement in the higher level language that you have. You save that code, then you compile it. If you don't have any syntax error, you can call it a good run. If you don't have good syntax, it keeps erroring out with the syntax error, that you have to repeat this step of correcting the code, saving it, and compiling it till finally you correct all the errors that find during the compilation. It should not have any error, zero error. There are warnings, however, that will warn you of certain circumstances that your program may fall into a wrong result in calculation, for example, and the compiler is just giving you a hint for those cases. Warnings are okay, but syntax error are not. After you got what we call clean compile with zero syntax error, then you run the program with a test data for the input, provided that it clearly take care of all different cases of the input that comes to you. You want to calculate with negative rate, with zero rate, with large rate, to see what happens to the gross pay in our case of the calculation. Of course, negative pay doesn't have any meaning to it. $0 wouldn't have any meaning to it. A large hourly pay would not have a meaningful result. So you have to make sure what you have as input is correctly taken in the program and processed and given the correct result as the output. If you have any logical error, you have to correct and rewrite the program to take care of the logical problem. Once you've done all these steps, then you want to validate the result and evaluate your program. And this cycle goes on and on till you take the program out of the production. This would be the end of section 1.6